Hey everyone, this is your host Aditya, and we are here with another tutorial on vRealize automation. Now that you're familiar with components that make vRealize automation, in this video, we are going to discuss the deployment types of VRA, which signifies the way these components can be deployed in our infrastructure and the different reference architectures associated with these deployments. Now getting back on track. The architecture deployments can be broadly divided into two types, depending on the number of virtual machines that we are willing to deploy our IaaS components on. The first would be the minimal deployment, and the second would be the distributed deployment. Talking about the minimal deployment is used when you have to give a demo or a proof of concept to a customer. In a minimal deployment, we can have 2 or 3 virtual machines based on how many components you decide to club together. One of them would obviously be the virtual appliance. The IS components can be deployed in 2 ways. Either you can deploy all the IS components on the same virtual machine, and then you will have your complete minimal deployment in only 2 virtual machines. Or you can deploy the IS database on a different virtual machine and all the other IS components on a single virtual machine, and of course, the appliance on one virtual machine. This way, you will have 3 virtual machines. These are the ways in which you can have your complete deployment. That is your minimal architecture. Now that we are done about the minimal deployment part, let's talk about the distributed deployment of vRealize automation. Also, I hope this doesn't sound redundant, but there are again 2 ways in which we can deploy distributed architecture, which are the distributed deployment without high availability and the distributed deployment with high availability. In distributed deployment, of course, we are going to deploy our virtual appliance, and the IS components are going to be distributed among different virtual machines. That is, instead of running all the IS components together on a single virtual machine, we are going to club and distribute them on different virtual machines. This increases the resources that each component can get from its virtual machine, and thus increases the load that our vRealize automation infrastructure can handle. This makes up for the distributed deployment without high availability, and the scenario is used when the load is high and can't be handled by the minimal deployment. As for the distributed deployment with high availability, all the components are clubbed and distributed on different virtual machines, same as in the distributed deployment without high availability, but there are multiple instances of each virtual machine running behind a load balancer to provide high availability. For example, you can have 2 or more virtual appliances running behind a load balancer. Also, as we discussed in the non-high availability distributed deployment part, you can have multiple components running inside a single virtual machine, and there are multiple instances of that virtual machine running behind a load balancer. You can just make a permutation and combination of the components together and have them running behind a load balancer. I hope you got the gist of it, as this is the usual deployment in the production environment with very high workloads, as this deployment provides the capability to handle such loads, as well as all the virtual machines running are highly available. That allows us to recover in case of failures. Now that you understand the logical deployment architectures, let us discuss the different reference architectures related to these. These are just some example deployments that have been classified as small, medium, or large by VMware. They give us a reference as to which architecture should be deployed and how, based on what kind of workload is expected from the VR infrastructure to be handled. The first one we have here is the small deployment. The small deployment serves as a starting point for vRealize automation infra, and you can even scale it later into a medium or a large deployment. A small deployment supports the following items. It can support like 10,000 managed machines, somewhat around 500 catalog items, and 10 concurrent machine provisions.
This deployment will have a virtual appliance whose portal the users will access. Also, an infrastructure core component that will host all the IS components except for the IS MS SQL database. The IS MS SQL database will be deployed on another Windows virtual machine. Now that we are done discussing small deployment, it's turn for the medium deployment. The medium deployment supports the following items. It supports about 30,000 managed machines, somewhat around 10,000 catalog items, and 50 concurrent machine provisions. In the medium deployment, you're going to have two virtual appliances behind a load balancer and a third one optionally. The third appliance, other than providing load handling, also allows for automatic failover of the vPostgres database. Now, this feature came from vRealize Automation version 7.3 and was not previously available. The basic requirement for automatic failover of vPostgres SQL is that the first condition is that you should have 3 or more virtual appliances present in your environment, and the second being the database of all these appliances should be in synchronous replication mode. Other than the two or three virtual appliances, we are going to have Windows servers, which are each going to host IS websites, model manager, manager service, and demo orchestrator. These machines will be behind a load balancer, where there will exist two different load balancer pools, one for the IS web server and the other one for the manager service. Other than that, we are going to have one or more dem servers, which are going to host multiple instances of dem workers at a given time. Since each dem worker can support execution of 30 concurrent workflows, the number of dem workers will be decided based on the workload that you have. Also, the number of dem workers in a dem host depends upon the requirement of each dem worker and the specification of your dem host. You can have all your dem workers running on a single dem host, but it's better to distribute them over so that in case your dem host goes down, you will still have some dem workers running on a different dem host. You're going to deploy your proxy agents on another Windows server. It is supposed to be deployed close to the endpoint on which it will provision, as this will increase the rate at which it collects data. The proxy agents can also be deployed in high availability configuration. Although only one remains active at a time, and because the other proxy agent is quite caring, so it keeps monitoring the primary proxy agent for failures and takes over its job in case it occurs. We of course have a MS SQL database that stores information regarding the IS components on another server. Now that we are done with the medium deployment, let us discuss the large deployment. A large deployment would support the following items. We can manage 50,000 machines at a time, 2,500 catalog items, and we can do 100 concurrent machine provisions. Just like in the medium deployment, we can have 2 or 3 virtual appliances behind a load balancer, based on whether we want automatic failover for vPostgres SQL database or not. We will also have 2 Windows servers behind a load balancer, which will each be hosting the IS web and the model manager. Another set of Windows servers will be hosting the manager service and the demo orchestrator behind a load balancer. Other than that, everything in the medium and the large deployment will nearly be the same. You will have dem workers on dem host based on your requirements. Proxy agents may or may not be in HA mode, and the SQL database can be in clustered mode. This concludes your distributed deployment with high availability. Now you know how architecture types should be selected based upon the requirements. This was all for this tutorial. See you in the next one. Adios.